everyone, and welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over solving systems of equations by substitution. We've already seen elimination, we've already seen graphing. Now we're going to see substitution and see, is this the way we want to solve the problems? Of course, sometimes we're told we have to solve by substitution, but sometimes we're giving the choice, and maybe this one would be our favorite. So let's see the steps on how to solve systems by substitution. So our first step is always to get one of the variables alone. We want to get an equation with x equals in a certain equation, y equals a certain equation, so then we can substitute that equation into the other and solve for the variable. Once we solve for that variable, just like we did in elimination, we take that variable, we plug that into one of our original equations, and we solve for the other one. So let's take a look at what we have to do with an example problem. So we have this problem here. We have the y by itself already. So we don't have to do anything of manipulation here because we already have our variable alone. So what we're going to do is take our equation and plug it into the other. So we have y equals 2x minus 8. Instead of y here, we are going to put this equation. So we're substituting that equation into the other. So I'm going to have 5x minus 3. Always make sure we have parentheses because we have two terms. We have to know we're multiplying the 3 by both terms, not just by the first one. So 3 times 2x minus 8, that no longer y, it's their 2x minus 8, equals 22. Then I'm going to continue. I get 5x minus 6x plus 24 equals 22. Once again, like I said for the elimination portion, we have to make sure we know how to solve our systems of equations with our solving equations. So if we don't know how to solve equations, we're going to struggle here. So that's why that was very important to understand. So now I combine my like terms. I get negative x plus 24 equals 22. Subtract the 24, I get negative x equals negative 2. We don't want negative x though, we just want x. So I need to divide by that negative 1, and I get x equals 2. Well, I just don't want my x though, I want my y as well. So I'm going to plug it into one of my original equations. I think the first one looks easiest. If we plug it into the second one though, we'll still get the same answer. So it's okay to plug it into either of the two. So I'm going to plug it into the top one. I get y equals, our x is 2. So I'm going to plug 2 in for x, minus 8. I'm going to do 2 times 2 is 4, minus 8, and that's my y value. So my y is negative 4, and we always have to write it as an ordered pair. So my final answer is going to be 2, negative 4. So these are the steps we're going to follow every time. We already had our y variable alone, so I didn't have to manipulate that equation. We plug it in, solve for the variable, plug that in, and get the y. We don't know if we did something wrong if when we plugged the equation and we had two different variables. I have an x here and an x here. If this was actually a y, then I did something wrong. We are trying to eliminate one of the variables, get rid of it, so when we substitute this back in, we have to make sure these are two different variables. Let's take a look at another problem that will make us have to use a step it up type. So now we have this problem, and rather than before we had x equals or y equals, we have our equations both in standard form. Well, we don't want that. We want one of the variables to be alone. So I'm going to look at each variable term and see which one would be easiest to get alone. Well, when I look, my coefficient of my x here is 1. So I can easily get that variable alone with basic addition or subtraction over. So I'm going to get that x by itself by adding 3y over. And my new equation is going to be x equals 3y plus 1. Now I have one of my variables alone, which is exactly what I wanted. So I'm going to plug that into the other equation. We can't plug it into our original because then we'll get infinite solutions or no solutions, and that wouldn't make sense. So let's plug that in. It wouldn't make sense for this problem. So let's plug this back in. I get negative 3. Instead of x, I'm going to have this. So 3y plus 1 plus 7y equals 1. All I took was my x equals and plugged it in for my x. Now I'm going to continue with my distribution. I get negative 9y minus 3 plus 7y equals 1. Combine my like terms, I get negative 2y minus 3 equals 1. Add my 3 to both sides, I get negative 2y equals 4. So my y is negative 2. Once again, once I get my y is negative 2, I'm going to plug it into one of the original equations, because what if I accidentally just took this negative 3y, plopped it onto the other side, and said I was good to go? That's not going to help us there. We don't want that. So if I plugged it into my manipulated one, I would just think, oh, I'm good to go. If you plug it into your original, you should get an integer, and you'll know you did it correctly for my problems. I know some teachers give fractional answers, but for mine, if I plug this back in and I get a fractional answer, I know I did something wrong. So I always plug it into my original to make sure I did it right. Obviously, maybe the odds are in your, like, against you, where you got the wrong answer, you plugged it in, you got an integer answer. It might just happen like that, but usually that's not how it happens. So I'm going to plug this in to my original equation, and I get x minus 3, my y is negative 2, equals 1. Now I'm going to use my multiplication. Negative 3 times negative 2 is 6. And then subtract 6 from both sides. And I get x equals negative 5. So my final answer as an ordered pair is going to be negative 5, negative 2. And you've got to make sure you write it like that so it's proper. Let's take a look at another problem to make sure we're fully understanding this material. So here's another problem where we need to get the x or y variable alone. So when we take a look, we have 2x minus 5y equals 7 and 2x equals negative 4y minus 20. So there's multiple ways to go about this. I'm going to show you the way that you can do it every single time, because sometimes it's not going to work out. A way we could do it is just take 2x equals this, we plug this in for our 2x and continue. However, a lot of the times we're not just given the same term here. We're not given 2x and 2x, so I'm going to show you the more complex way, because that's what you'll be seeing more often. So I want to get the x by itself. So I'm going to divide everything by 2. I'm doing that to get the x alone, like I've been saying. So when I divide by 2, I get x equals negative 2y minus 10. I'm going to plug that in to my first equation for x. So I'm going to do 2 parentheses negative 2y minus 10 minus 5y equals 7. Then I distribute. I get negative 4y minus 20 minus 5y equals 7. Combine my like terms. I get negative 9y minus 20 equals 7. I'm going to add 20 to both sides, and I get negative 9y equals 27. So my y equals negative 3. Once I get my y is negative 3, I'm going to plug it into one of my original equations. So I'm going to plug it in to this one. So I get 2x equals negative 4. My y is negative 3 minus 20. 2x equals 12 minus 20. So 2x equals 12 minus 20 is negative 8. So my x is negative 4. And once again, I need to write this as an ordered pair. So my ordered pair is going to be negative 4, negative 3, and that's my final answer. So whenever you see a variable with a coefficient on the left-hand side, we want to get that variable alone. Once we do that, we plug it in, keep on going, got my y, plug it in, find my x, write it as an ordered pair. Let's try one more problem to make sure we are understanding this. So now we have this problem. We have 6x plus y equals 0 and 12x plus 2y equals negative 7. I see here that I have a coefficient greater than 1, where here it has a coefficient of 1. So let me get this by itself. So I'm going to subtract 6x from both sides, and I'll get y equals negative 6x. Now I'm going to plug that into one of the other equation, and I get 12x plus 2. My new y becomes the negative 6x equals negative 7. Now I get 12x minus 12x equals negative 7. At this point, we know that 12x minus 12x is 0. We're not going to write 0x because then a lot of us are like, well, there's still an x there. No, there's not. It's gone. So I get 0 equals negative 7. We've seen from all our different types of solving equations, from solving systems, that if we get 0 equals a number that's not 0, that's going to be a no solution. So the answer to this problem is going to be no solution. However, if I got this up here, if this was 0, this would be 0, this would be 0, and if we ended up with 0 equals 0, or let's say it was 4 equals 4, that would be an infinite solution type of problem. So these are all the different types of ways that we could solve a systems by substitution. I hope these were helpful to assist us when we have these type of problems.